Yeah, yeah. In the last class, I was discussing about types of algorithms, right? Okay. Predictive and prediction algorithms, right? Supervised two types. Supervised means in the last class I was saying, right? Yes. Supervised means input variables, target variables, response variables, both are required. Input variables required and target variables required. Here, example regression, classification. Regression, we have got linear and non-linear. Classification algorithms, 6 types. Logistic regression, decision trees, random forest, support vector machines, naive Bayes, and KNN, K nearest neighbor. That is in prediction algorithms. In clustering algorithms, unsupervised means only input variables are required. Target variables not required. Like partitioning algorithms, K means K medians, hierarchical algorithms like agglomerative approach, divisive approach. Recommender engines, right? Like 2 types. Pattern matching. Yeah, what association rules, a priori algorithm, FP growth. And collaborative filtering, 2 types, UBCF, IBCF, user-based, item-based. And one is graph-based. Okay, talking about this first one, regression algorithms. This regression classifications clustering mostly used. Regression algorithms means predicting a continuous value for a target variable. Predicting a continuous value for a target variable. Tomorrow, what is the temperature? It's a continuous value means numerical value, right? Okay, tomorrow, what is the temperature? Numerical value. What is your age and what is your rank? What is your age and what is your rank, right? Yes. Means age is numerical, rank also numerical, right? Age is numerical, rank also numerical. Linear regression. That is what example of this regression, linear regression. So it is going to predict a numerical value, continuous value, right? Classification algorithms, right? Predicting categorical value for a target variable. Predicting a categorical value, right? Tomorrow will it rain? Yes or no? It's a category, right? Yes category or no category. It's not numerical, not continuous value. Will you pass the exam? Yes or no? So here linear regression, non-linear regression comes in regression. Logistic regression comes in classification. Logistic regression comes in classification. So yes, what is the difference between regression and classification? Observe here, what is the difference between a regression and classification? Here both input and target variables are continuous. Both input and target variables are continuous. Means input variable temperature sales, temperature sales, temperature sales. Both are continuous. But here in logistic, input variables are numerical, whereas target variables are categorical. For example, input variables are like this: age value, height value, weight value. Age is given, height is given, weight is given. 25, 6.2, 97. Age is 25, height is 6.2, weight is 97. All these are numericals, input variables. Target variables are what? Categorical, saying yes or no. Here input, here based on input, whether the person based on input variables. Here based on input variables, whether the person will win the weightlifting championship. Here based on input variables, whether the person will be win the weightlifting championship, yes or no. So based on this means based on his age, based on his height, based on his weight, whether he will win the weightlifting championship means yes or no. Means what is the difference between regression and classification means here both are numericals. But in the case of classification, you are classifying to S category or no category. So input will be numerical only, but output target variable only will be in categorical format. Now, regression models. To predict a target variable, which is a continuous value. Linear regression, non-linear regression. Linear regression and non-linear regression. And also like quadratic regression and cubic regression. Lasso regression and ridge regression also there, but mostly this linear and non-linear only prefer. So we have advanced tools like decision trees regression also, right? For classification also it is available. Decision trees classifier, decision trees regressor also available. Okay, target value is continuous. Target value is classifier. Okay. Random forest regression also available, but only these are the main things we see. Between the features, between the features and the classifier, if the commonalities are high, 40 to 60%, then the above listed algorithms won't work. So for that, another algorithms like support vector machines, SVR and SVC, support vector regression, support vector classifier is there. Okay. So just observe here in this regression and classification, both are predictive algorithms. Predictive algorithms, right? This predictive algorithms, regression and classification. Predictive algorithms are supervised. Means both input and target both are required. Here, input is numerical, output also numerical. Input here in the classification, input numerical, output will be categorical. Category, right? Yes. Okay, for example, salary. Categories like high salary, low salary, medium salary. So if it is input 95,000 high salary, means the input is numerical category. 10,000 low salary, 60,000. So here input is numerical, output is categorical. Category, right? Different categories. Check, for example, numbers are there. 2 is there, 3 is there, 4 is there, 7 is there. Category, what category? Even category. This is odd category. This even category. This is odd category. Even and odd category, right? So here classifications input will be numerical, right? Continuous values. Output will be categorical, even odd. But in the case of regression, input and output both will be numerical continuous values. For example, regression. Where temperature is 25, sales 30K. Tomorrow also temperature 25, around 30K you will be having that sales. If temperature of the cool drink, for example, sales of cool drinks, if temperature is 10, the cool drinks like 15K, it will be decreased, right? So both are numericals based on this input, output. Based on input and output, we are predicting this. If the temperature is 10, it will be, if temperature is 40K, 40, and the sales will be 45K. Yes. So let us go with this regression and classification. The regression and classification practicals, right? Like for the regression, linear regression. For this classification, logistic regression. Yes. Open this PySpark, right? Control Shift to T, PySpark. So linear regressions, right? Okay. Predicting, it is supervised learning. Once again, I'm saying supervised learning based on input and output variable, the prediction is going to happen. And logistic regression it is also supervised learning, right? Both, but only clustering algorithms are unsupervised. Okay, check this notepad. Regression and classification. These are two forms of supervised learning. Supervised learning. So here, input variable means features, I said. Output variables means label. Output variable or target variable means label. The above algorithms use. The above algorithms, right, use labeled point class. Labeled point class. It consists of a label and features vector and features vector. The above algorithms use label point class. Label point consists of a label and a features vector. Label is a double data type. Now just check the accuracy measurement. Formula for accuracy measurement. The closeness. What do you mean by accuracy? The closeness between actual value. Actual value. Actual means y. And predicted. And predicted means y cap. Y cap. Is given as absolute of 100 minus absolute of y minus y cap into 100 into 100 by y. Okay. Example 1. For example, if I go to HDFS, LS I'll create, for example, sample cat samp1.txt. I'm creating one samp1.txt file. Temperature value and sales value. Temperature and sales. Temperature 25. Sales 30. Temperature 25. 1 second. Samp1.txt. Temperature 25. 30 is the sales. Temperature 27. 32 is the sales. Temperature 29. 34 is the cells. 31, 36 is the cells. Temperature 33, 38 is the cells. 35, 40 is the cells. 37, 42 is the cells. 39, 44 is the cells. Control D. Temperature and cells. Let us see the practical of it, right? From NumPy, import array. NumPy, import array. Nakunda prompt. New Python 3. From NumPy. From NumPy. Run this. PySpark dot ML from PySpark ML dot linear algorithms import from PySpark dot ML import vector. Run this. From PySpark dot ML dot regression. PySpark.ml dot regression. Import label point. Forgot.
Otherwise, why you are importing the NumPy? What is that?
And you'll be using NumPy array.
Hello?
Yeah, I'll be using NumPy arrays in my code. In my code, I'll be using NumPy array.
Is it something is feature or to Python?
NumPy is a Python module. Like found NumPy is also one module, right?
Okay, okay.
Sorry, 1 second. Say enter one. And here from NumPy is a model from, from PySpark.
Sir, initially you typed it on in the VMware. So why it was not working there?
Doc linear algorithm. Linear algorithm. So to install this NumPy module, we need to install NumPy module. NumPy module is not available, right? Okay. So here the Jupyter models will be available in built models. Most of the models will be available, but in that Linux environment, right? We need to install all the modules. PySpark.ml.
Your voice breaking in between now. Vijay.
Is my voice? Are you getting any breaks in my voice? Everyone try to respond.
Now it's fine. It was breaking up.
Sir, you typed it on the VMware Linux machine. So why it was not working there?
NumPy module is not available in there. So we need to download and install each and every module there. Here in this Jupyter notebook, all the modules are available. Controller. Repeat install Python icon. Now type password. Yes, say yes. Yes. Now check it. Well, right. Mm, Python. So here we need to install each module separately here. All the modules, Python has got thousands of modules, right? Which module you are using that we need to install it. So one, import application. Yeah, it's working, right? So what we need to do here? The install now. First, what module, right? Within the terminal, everyone says sudo. So we use sudo. NumPy. Now it is not giving error. Previously it was giving error, right? So even in the coming topics, if you got any another module also, we need to explicitly type. In the Victor notebook, all that will be available. Okay. From Python dot ml dot linear algorithms. So all these are linear PySpark. In the PySpark, we have got ml, we have got linear algorithms. That import vector.
So what is in this package, Vijay? It's like fastpark.ml leave and lang package. What is that actually? Can you explain about this package?
In PySpark, we have got
Yeah.
ml. Within the ml, we have got linear algorithms. From that, import vector. Vector is a
So
class.
so linear algorithm is which we are going to study right now. That's separate package is there. It means right?
So vector is a class. Within that, we have got a module linear algorithm. Within that, mlib is a sub package. PySpark is the main package. So we need to import whenever you are using any of this, right? We need to import this.
So every algorithm is having the separate package. You mean
Every
algorithm? We have a separate
yes,
package.
every algorithm is we have got sub in machine learning library. We have got different modules are available.
Okay.
Next, ML PySpark. dot regression import label. Import. So from PySpark.ml lib dot regression import labeled point L capital T capital. From PySpark again from PySpark.ml.regression. We're talking about regression algorithm, right? In that label point is right. And one more, the algorithm what we are going to discuss, linear regression. Linear regression, right? Linear or capital linear regression with S, S, right? Stochastic gradient descent. Linear regression with GD, that is what from ML lib regression, right? Loading the controller. Okay, this one. Um, this hyphen. um,
Voice is low, Vijay.
What is it? Voice is low.
Yeah, now it's fine.
HDFS DFS hyphen put sample.txt. PySpark. What? Yeah. Yes, enter. Right. I'm copying the sample.txt into HDFS directory. Sorry, 660 from Control L. Yes. Copy into that directory. PySpark 6:30 p.m. Right. PySpark 6:30 p.m. Right. Check it. And at PySpark 6:30 p.m. Ah, file. So file I'm loading it. Forward slash. That from that. So one. You notice RTD is created here. Okay, now see that comma delimited. It is comma delimited. Comma is there. Step 2. That's step 2. Comma as delimiter. Comma as delimiter. Previously we discussed that using map. The dot map lambda whenever you are using it, each element comma delimiter. Yes.
We are not able to
Split one.
voice is breaking. Can't hear you.
Am I audible to all or not?
Yes.
Hello. Yes.
Yes, you are.
Are you getting any breaks in the middle?
Now
No.
it's fine.
No, nothing, right? So it is from that other side, the person who was asking, right? So split one, data dot map, data is an RTD dot map lambda x. X means what? Here x means what? Each string if you split based on comma, you will get a list. For each string if you split, you will get a list. Okay, just okay, we'll see this. What is the output for this, right? Say enter. Now split one dot collect, you say once. Split one dot collect, you say. You can check this output, what you are going to get. Yeah, split one dot collect. Okay, you will get list of list, you will get. 1 second, hold on, right. You got list of list, right? Yes. 25, temperature 25, yes. Sales 30, 27, 32, 29, 34, 39, 44. List of list. That is Unicode. U indicates the Unicode format. That is nothing to do with that. Yes. Next. For example, S2 equal to split one. Split one is there, right? Dot map. I want both as float types. Input and output both has to be float type. Split one dot map. Both I want like a float type, floating point. So here I said, right? 1 second. Both I'll be taking as float type. Label is a double data type, means double means float type. A label point consists of a label and features. So here we will take everything as okay. Split one dot map lambda x. X means each element, right? First element is first list. X means it takes the first list from the first list, right? X means first list from the first list. Float of x of 0. X of 0 is integer 25. Make it as float, comma, float of x of 1. Float of x of 1. Close this. Close that map. How many 3 brackets required or 4? Check the brackets properly. For float, 1 is closed. For that, okay, whole bracket. For map, 1 is closed, right? S2 dot collect, you say S2 dot collect COLL is it. Now you will get as float type. Everything you are going to get as float types, right? In this phase. List of tuples, list of tuples. Now I need to now transforming the list into labeled point. Step 3. So transforming the list into labeled point.
Hello, what you did in after a split actually is not S2 is called a split dot map.
I just converted into float type.
Why is there
This
reason to
this
convert in the
conditions.
plot?
See, actually, what algorithm is expecting, that values we need to provide. It is expecting floats. Algorithm is expecting float, that too in labeled point format. I'll say what, okay? What do you mean by labeled point? So why I'm converting to float and why I'm,
And we converted list to tuple also, correct?
yeah, I converted the inner list, each list into tuple, and also each value I have converted into float type.
And why we converted to the tuple? Any specific?
See, generally key value type, right? Key value
Yeah.
type. Key value format will be like tuple type only, right?
Okay.
Okay, now transforming the list into labeled point. What is labeled point? I'll discuss. Okay, now transforming the list into labeled point. People who have already got knowledge on ML, machine learning, you will be understanding these things, right? This technologies, label point, features, label. This should be in comment. Step 3, we need to keep this. Now transforming the list into labeled point. The list, transform the list into labeled point. Okay, fine. Now convert, this is also comment. Now converting each element labeled point. Labeled point. Labeled point consists of labeled point consists of two parameters. Labeled point consists of two parameters. What is it? Label. Observe carefully. Labeled point consists of two parameters. One is label. LA. This is also I should keep in comment. First one is label. 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 Label nothing but output variable. Label means what? Output variable. Understand here? Why I'm converting all this means your algorithm is expecting in what format. You need to transform your data into that format. Now, transforming the list into label point means my algorithm is expecting labeled point. What is labeled point? It consists of two parameters. First one is label means output variable. Output variable, right? Yes. It should be of float type. It should be of float type. Second is what? Second one is features. Features. Features means input variables. Input variables and output variables, right? So label point consists of both. So this input variable should be of, which is a dense vector. Which is a dense vector. How to create a dense vector means create using NumPy array. Hmm. Create using numpy array. Create using numpy array. That is array of numpy array of 1.0, 2.0, 3.0. Understand this? Create using numpy array. That is array of 1, 2, 3. Sir, comments. Now two things, right? So label point consists of two parameters. That is output variable and input variable. Input variable should be a dense vector type, like numpy array of 1.0, 2.0, 3.0. And first one, output variable should be a float type. Now labeled point. I'm creating a labeled point. LP equal to, what was that previous one? What was that RTD name? S2, right? S2 was the RTD name. S2 dot map the output of it. S2 dot map the output of it. S2 dot map. S2 is the RTD map. Lambda x means each element. Each element of that S2 is what? A tuple. Now convert into, yes, labeled point. Each x is a tuple, right? Each x is a tuple. Convert to labeled point. Labeled point of what is in the labeled point, what is the first one? Everyone try to answer. In the labeled point, what is the first parameter? Hello? The labeled point consists of two parameters. What is the first parameter?
Output parameter label.
Label, right? Label. Label means which one? X indicates each element, this one. In the each element, what is label here? 30 is the label. 25 is what?
Input.
Input variable, right? So here what I should say? Label point of x of 1 will be the label, right? X of 1 will be the label. And x of 0 will be that. So
Input.
features, input variables, which is a dense vector, which is array type, right? So numpy array I will take. I'll convert it into numpy array of x of 0. So only integers you cannot convert to numpy array. Only list only you can convert. So make it as a list. In that list, only one element x of 0. So normal integer you cannot convert to numpy array. List, I am converting that into list. Closing this labeled point. Three brackets you should get, right? Understand this, what I did? I am creating labeled point. In the labeled point, first one should be the label, that is output variable. Second one should be the input variables, right? It should be of array type. What is it? Numpy array type. Now check it once. LP dot collect, label point dot collect, label point dot collect. Now you'll get all as label point format. All are label point, label point, label point, label point, right? So now building the model, next step, step 4. Step 4 is what? Build the model. Build the model. Okay. How to build the model? How many more iterations you take, more accurately you are going to get. How much more accurate, how many more iterations you take, that much more accuracy, right? For example, I'll say labor example. Why that accuracy? For example, what is the average weight of the uh, people, means males? What is the average weight of the males between 25 to 45 in Hyderabad? Take how many iterations? For example, if you take only, if you go to a particular person, if we ask his weights, he said 90. So can you declare that average weight of all the Hyderabad males between 25 to 45 is 90? No. You check with 2 people, 10 people. 10 people, okay, you will get some averagely like 85 you are getting. That too, it won't give a full exact, right? So check with 100 people. 100 people also you are getting some 82. 1,000 people you take. It is, you are getting somewhere like 79. With 1 lakh people you take 78, you are getting 77, right? Which one gives the higher accuracy? With one person performing the average, or with the 1 lakh person doing that average? Hello? Which one gives more accuracy? If you're performing average with 1 person or 10 persons, all the 10 persons are overweight. All the 10 persons are overweight, assume. All are above 100. But if you're taking 1 lakh or 1,000 or 1 lakh, right? They cannot be all overweight. So it will give exact accuracy, right? So that's why more iterations, more accuracy, right? So build the model. So number of iterations, number of iterations, right? Iterations equal to 100. So what is the model name? Name of the model. Linear regression with SGD. Linear L capital regression. Regression. Regression with SGD.
Hello, Vijay. I did not understand number of iterations. Could you please once again explain it?
All the ML algorithms are iterative in nature. First, if you apply on a particular, if you are applying right on a data, it gives some error. I'm asking you, so okay, I'm asking you to just predict my age. I'm asking you to predict my age. I'm giving you only one choice. Try to say my age. You are saying something somewhere, okay, some value you have given. It's wrong. If I give 5 iterations also, it is wrong. But if I give 50 iterations, you will be accurate, right? Hello? If
Okay,
I'm
so
providing more number of iterations for you, the accuracy will increase.
okay, so number of iterations means number of chances you are giving.
Yes,
Like,
number of iterations, right? Number of iterations. For example, if I provide more, the more accuracy. First time, for example, there is an apple on the tree. You are hitting that apple with a stone. So your stone went low below the apple. So with what angle, next iteration, what you will do? You will increase the angle so that it will go a little bit high. So still it went low. Means if I provide you more iterations, right? You keep on trying until the error becomes 0. First time the error was 70. Means the length between the apple and your stone is 70. Second time, it became 50. You will adjust that coefficients, right? And you will again hit it. Again, you will adjust it. So you got 40. Again, you will adjust and you will get 30. Okay. Again, you will adjust. Okay, still I need to go for high, means still you will keep on trying. Error becomes 70, 60, 50, 40, 30, 20. Finally, error became 0. Means in ML algorithms or iterative algorithms, you are keep on applying that algorithm on the data. So first you will get some error. Again, you will apply. Again, you will get error. Second time, you will get error little less than the first one. Third time, you will get error little less than the second one. Every time the error will be decreasing until it becomes 0. You are going to hit the target. So that's why here, if the more iterations, more accuracy will be. Less iterations, the accuracy will be little less. So that's why number of iterations I have taken as 100. Linear regression with SGD. You're training the model, right? Train with the LP means labeled points. With labeled points, number of iterations. Number of iterations.
And what is this linear regressions with SGD?
That is the model that we are using. That is the name of the model that we are using, right? Inbuilt model.
Of linear algorithms.
It's a built-in, right? Linear regression with SGD with the same thing. We need to provide it. Where it is present, I've imported right here. Can you see up? I imported it. This is what I'm going to use, I said. The regression, machine ML live with the regression, right? I'm going to use this linear regression with SGD. That is the name of the model I'm trying to use.
So here you use the train, function. So by providing the number of iterations and it's like a
So
number.
just before I showed one example of stone, right? Every time iteration and that you are adjusting the coefficient. Every time you are adjusting. So LP is the labeled point, number of iterations, and what is that coefficient you are adjusting every time? 0.0001. Every time I'm giving some value, give some value. So here, labeled point, number of iterations, and that what is that coefficient value, right? Every time you are providing some value.
What is the use of coefficient value?
That is a modification error we say, or intercept value we say. First one is labeled point, number of iterations. Third one is modification value or modification error or intercept value we say, last one. So every time you provide some value so that. So here, every time you want, see here, first iteration, second iteration, every time you with 0.001%, 0.0001, right? In each iteration, you're modifying the error with 0.001. Then only the modifications occur. Otherwise, the same value, right? Every time you're modifying with some value, right? That modifier value or intercept value we say. Okay. Three things are required, right? LP, number of iterations, 0.001001, right? Yes.
So this value can be anything, right? Equation value.
What is it?
This value, third parameter value can be anything, right?
See here, 1 and 1.001 doesn't make much difference. But if you're adding 50 means lot of difference, right? Angle.
Yeah, correct.
Understand one, sir. To 1, if you're adding 1.001, next time I'm trying with 1.001. Next time again add 1.001. It doesn't make much difference. Means slow, slightly I'm increasing the values. Check it, right? But if you're not going with a major value like to 1 adding 50 means lot of difference you observe. So the second and third parameters are optional. Even if you won't get, you provide also, you will get the output. Second, first one is only this labeled point is compulsory. The second and third, not required actually. But you are providing with some iterations and some values. Now, enter you say. Now we are training the model with this. So it takes a little bit time, right? warning messages. These are warning messages. Okay. So here I'm writing, it takes, here I'm writing a comment, right? Yes, comment. It takes 1 second. It takes 3 parameters. What are 3 parameters? Labeled point. Okay, number of iterations and this.
Hello, Vijay. Can't see your screen actually.
Able to hear my voice now? Yes. Hello. Yeah. So here, if we talk about this labeled point, number of iterations, and this, it takes 3 parameters, right? It takes. Okay. First, I'll copy up to here, right? I'll copy this. Yeah. Okay. No, up to here understood, right? Yes. Here LP numerical, okay, number of iterations 0.001, right? So here, what are these 3 parameters? What are the 3 parameters, right? First one, labeled point. Labeled point it is. Second is number of iterations. Number of iterations. Third is modification error. Every time we will be modifying the value, right? Modification error or intercept value. Here I'm writing second and third parameters are optional. If you're not providing anything, by default, it takes some optional values. Observe this next step. What was the previous step? Step 3 is there. Step 4 is here. Okay. Step 1, step 2. Step 2, this is step 2. Step 1, step 2. Step 3, step 4, and step 5. Step 5, right? Now. Step 5. Evaluate module. Evaluate the model on training examples. Evaluate the model on training examples and predicting. Right? Yes. For example, Control L. For example, test results I want. Test results equal to what was the this LP is there, right? LP means labeled points. All this labeled point. LP dot map. LP dot map. Lambda lambda x. X means each labeled point.
Vijay, this LP is also RDD, right? Yeah.
Okay. LP is also an RTD. Yes. That's why I'm saying LP dot map now. What is X indicates here? Each element. Each element is what? A labeled point. Labeled point. In that you have got this is label. These are features. Labels and features are there, right? Now here what I'm doing, LP dot map lambda x. Simply what I'm doing, x dot x is that each element in that label. It will automatically takes the label. Label means the first one, the first parameter. Next here, I'm asking the model. We have given training to the model, right? With some number of iterations and with some modifying, right? Now using our model as to predict. Model dot predict, I'm applying our model dot predict. Based on what it has to predict? X is dot features, based on features. Model dot predict based on features. One more bracket.
Second parameter is the output parameter, right? Input parameter, right?
So here clearly try to understand here, right? What I said here. Labeled point consists of two parameters. First one is label, output variable. Second is features, input variable. We have transformed the list into labeled point. In the labeled point, we have got first one is output variable, second is input variable, that is a dense vector. So what is this x of 1 here? Output variable. X of 0 is what? Input variable. First we are taking what? Label. Next, input variable. So here what is it? X dot label. Label automatically takes, but predict based on X dot features. Okay, say enter. Understand this, right? Yes. Here test. Okay. 1 second. I'll copy this. And now, what is X dot label here? X dot label means already output variable, right? Target variable.
So what is model here? Vijay? Model dot predict. How?
What is this here?
Okay. Okay, you have converted this model. Okay, fine. You have given the trained model. Okay.
And applying the model to predict based on these features. So here X dot label, that's what I am trying to write here. X dot label means what? Actual value. Actual value. X dot label is what? Actual value. That is why we say. Actual value y. Now, what do you mean by this predict X dot features? Predict X dot features means this is actual value. X dot features means it is predicted value. This predicted value y cap. Understand here. We are predicting based on features. This means this indicates what? Whatever it is predicting, it is predicted value. Actual value is what? Now just observe this output, right? test results dot test test result dot collector test result dot collect you say. You'll get the output. This is the actual value. This is the predicted value. This is the actual value, predicted value, actual value, predicted value, actual, predicted, actual, predicted, actual and predicted, actual and predicted, right? Yes. You got this, right? Actual and predicted values you got.
Predicted value, what actually giving here? If temperature is 30, then sales will be 24 around something like that.
This y is what? This actual value. Y cap is what? This predicted value.
No, my question is that yeah, first like 30 is the temperature, and the second value it's predicted like sales one, right? That's an example.
Your age is 25. I am predicting is 22. This is what? Your age is 30. My prediction is 24. Second person age is 32. The algorithm predicted as 26. Third person is 34. 28.
The prediction is the, I did not understand here. Like first person's age is 30. Prediction is 24 means what actually here? The next upcoming person's age will be 24 or what?
What you are trying to do in this algorithm, right?
I think
You're trained the model, and I'm asking the model to predict how the model is predicting. Okay, now check this. Okay. This is what do you mean by this second value? Y cap. What do you mean by Y? Actual value. What is Y cap? Clearly I mentioned here, right? Y is what actual value. Y cap is predicted value. Hello.
no, actually I'm not able to relate with the real time example here. If no, so if you given the example for the age, if person's age is 30 years, how it would be predicted 24 years or maybe 26 years or something like that? Because based on the data or what?
Step 6. Accuracy measurement. Accuracy measurement, right? For example, 1 second. A is 1 person, B is 1 person, C is 1 person, D is 1 person. A has to predict the age. A has to predict the age. Age is 30. Predicted value is also 30. 100% accuracy in the prediction. Hello. Your age value 30, the person A has predicted the age also 30. 100% accurate. Person B is there. What he did? Age was 30. But prediction was he has predicted like 28. So is how much? What is its accuracy? 90% accurate. Person C is there. 30. 50% accuracy. So this is actual value. This is y cap value. Actual value is what? 30. Predicted value 30. Actual 30, it predicted 28. 30, 25. This is for one person. So for all the values, how many values are there? Okay, 30, 32, 34, 36, 38, 40, 42, 44. Now I'm trying to observe the accuracy of this algorithm. I'm just going to try to check the accuracy, right? So it was 30 actually, but what it has predicted in this way. 32 actually, but what is my algorithm predicting? 26.8. 34, it's predicting 28. Now see this accuracy measurement. Now I'm doing the accuracy measurement, right? You will get that how much accuracy it is predicting. Right. So there is a formula for this accuracy, I said, right? Yes. Accuracy measurement. So here accuracy equal to yes. Accuracy equal to yes. Test results test res dot map that map, right? Lambda x. What is the formula for accuracy measurement? Now I want to test how this. So what is that? There is nothing to understand here. Your 30 is your actual value. Where is it? This label, this target value is 30. Now I'm asking by providing this input data, I'm asking you to predict it. I'm asking you to predict it. What it has predicted? The predicted value is 24. For the second record, 32 is the output variable. What was the prediction by the algorithm? 26. For third one, 34. Now I want to measure accuracy measurement. What is the formula here I've given, right? Where is it? Somewhere I've written. Accuracy measurement, absolute of 100 minus absolute of y minus y cap into 100. This is the formula for accuracy measurement, right? Now, the same thing, right? Try to do here. Accuracy measurement, test results dot map lambda x. Now try to say absolute of 100 minus absolute of x of 0, absolute of x of 0 minus x of 1, absolute of x of 0 minus x of 1 into 100. X of 0 minus x of 1 means y minus y cap by y. X of 0 is y. X of 1 is y cap into 100 by x of 0, that is y. One, two, where is the one more value? Wait, yes. Check it. Now accuracy dot collect. Now what is that accuracy? See, the first one 82% accuracy means 30 and 24. 32 and 26, 83%. 34 and 28, 84, 85, 87, right? Yes. Now, these are the test results. How much accuracy, right? The algorithm has predicted, right? 82, 83, 84, 85, 86, 87, 87, right? Yes. Yes. Now, step 7. Step 7, right? Fix a benchmark. Fix a benchmark for success or failure of a test. Fix a benchmark for success or failure of a test. Fix a benchmark for success or failure of a test. Means, for example, if the algorithm has predicted above 86%, 86% benchmark. If my algorithm has predicted 86%, more than 86% benchmark for pass, else fail. 86% benchmark, if it is above 86%, pass, otherwise fail. For example, DF statistics. F function I'm defining, statistics X. So here, X, I'm defining a function here. And what is it? 1, 2, 3 I'm taking. What is it? In indentation, 3 spaces indentation. If that X value greater than or equal to 86, 1, 2, 3, 1, 2, 3. This is if indentation. Return pass, PASS. 1, 2, 3. Else. 1, 2, 3, 1, 2, 3. Return fail. Indentations required proper indentation, right? Fail. Now test statistics. Test statistics equal to, I'm applying this whatever this accuracy you got, right? This accuracy dot map. Accuracy dot map. Lambda x means each element. Apply function statistics of each function. For each value, apply it. For each value, apply this function. The function says either pass or fail. So just what I'm doing, function I'm applying to each value of accuracy, right? Yes. Enter. Now say test statistics dot collect. It will say pass or fail, whether how many test predictions passed, how many predictions failed. Check it. Fail, pass. First 4 are failed, last 4 are passed. Now you have set a benchmark, right? Above so and so prediction it is pass, otherwise it's fail, right? So in that step 8, Step 8. To know how many passed. To know how many passed and how many failed. To know how many passed and how many failed, right? Count by key, count by value is there, right? Count by key and count by value. Here we need to use count by value. Test statistics is there, right? Yes. Test statistics. Test statistics dot count by value. Count by value. It's a test statistics in RTD. On that RTD, I am applying count by value. V capital, right? Count by value means it gives a dictionary. Already we have seen, right? Dictionary. How many pass, how many fail. So four of your predictions have passed. 4 of your have been failed, which didn't reach your benchmark. If all of them failed means it's there is no prediction done by your algorithm. Model as predicting. Model, there is no model accuracy, right? Yes. Understood this, right? Yes. So here, what I did first, I applied this model. I trained that model. First, your model is expecting labeled point. You are transformed as per labeled point. Next, what I did, model. I'm creating a model. I'm building a model. How you build? By using the label point, which consists of label and input variables, number of iterations, and this modification. Now, evaluate the model. Just x dot label is what? The output variable, and predict based just like output variable, the prediction based on the input features. So you'll get actual and predicted. Now accuracy measurement by using this formula, accuracy measurement 82%, 83, 84. I am setting the benchmark 86. If 86% means only this is perfect prediction or accuracy, that is benchmark for pass, else fail. How many pass and fails? Right, this many, right?
Vijay, one dot here. You have given the taken the example the temperature sales, right?
Hmm.
How it's related to that actually, but I did not understand here actually.
Hmm.
Like the first input now you have taken for the sales and temperature, right? Here the 25, 30 is the sales. How it's related to this
See
trend
here,
model actually?
temperature is 25, 27, 29, 31, 33, 35, 37, 39. Okay.
Yes.
What is that sales? 30, 32, 34, 36, 38, 40, 37, 34 to 34. So you have provided all this. You provided this input and output, all this to your model. Labeled point you have given, which consists of both input and output, right? You have given this labeled point to the model. Both input and output you have given. After giving, right? So labeled point consisting of target variable and this input, target and input. Now, after giving what, after training the model, I am checking the model, how it is performing, how my model is performing. I'm performing a check. How evaluating the model on the training examples and predicting. On the training examples means, okay, already a labeled point is there, right? I'm applying on the labeled point. I'm applying on the labeled point. What labeled point is consisting of labeled and features, output variable and input variables are there. So what I am doing, x dot label means, okay, directly the output target variable. So I'm applying the model, whatever you have trained to predict based on the input. Based on the input means, for example, I'll ask you, when temperature is 33, what is the sales value? 38. What is the sales value? What is your output? I'm asking, tomorrow temperature is 39. What might be the sales? What might be the sales?
44, right?
So this entire data is provided. So it has evaluated, this model is, we have built a model, and the model, what it is predicting, clearly you say, you are predicting okay by seeing that. What the model is predicting for the temperature, tomorrow sales, that is sales was 30. But based on the input features, right? What was the input feature? Temperature was first one. See, the temperature was 25. I am asking to predict the model based on this 25. What was the sales it has predicted? You see, what was the sales it has predicted? 24.
Okay.
For the second one, actually 32 is the sales based on the input 27. I'm asking it to predict what are the sales means. The prediction of the algorithm was 26. Means how much difference in the prediction you see? How much accuracy it is? If it has predicted 30 means 100% accuracy. If the model has predicted 30 means 100% accurate. But how much accuracy it is now? Hello?
Yes.
That I calculated here in the next step. Between these two, what is the accuracy? 82%. If it was predicted 30 means 100% accuracy, right? Understood? Hello?
But if we change the coefficient value, this value prediction will be changed.
After changing with 100 iterations, it has given this. If you have given 50 iterations, somewhere like 22 or 20, 21 or 20, you should have got. 50 are just once you change and check, right? With 20 iterations or 10 iterations, somewhere it will predict 18 or 19.
Okay.
So
If you have
here,
given 100 iterations, now where is your query here? Who is this? Yes, Manish
Vijay,
Kumar. Manish Kumar, where is your query here? What you are not understood here?
no, understood here now, but one more dot here, Vijay, actually.
See,
So now,
one thing, if I want to make you understand all this, right, it takes 2-3 months if I discuss all that basics of this, right? So directly I went with that practical part. There are a lot
uh,
of things you need to understand. That's why you will feel, because I cannot discuss all those things. It takes 2 to 3 months more if I discuss all those, right? So that's
yes,
why here up to what extent I can make you understand, I can make you that how we are implementing this. So here RTD, lambda, and here what is that count by value, and that's in a simple way I was making you to make you understand. So here even I'm covering what is label point, what is label features, everything here. Yes.
so how we will be trained the model like above example, Vijay? Like if we have given like increasing the sales by uh, 5, rupees, right?
What is
So in the our above examples, above examples. So if the sales and temperature is 30,
see one thing. Here, how is the prediction of the algorithm? In this way, if I use the linear regression, if I use logistic regression, if I use support vector machines, there are many algorithms. Which one gives the high accuracy, right? Better accuracy, then use that. Generally, which algorithms gives the good accuracy, then select that algorithm. Here, this algorithm, what was the final result for this? 4 test passed, 4 test failed. Apply the same thing to different algorithm and check how many. For example, for that, all it has predicted above 90. All the tests are passed, right? Means it has got good accuracy than this. So which algorithm gives, which algorithm provides for this particular data, right? So that algorithm to be used. But whenever, okay, here once you got this accuracy, right, based on this formula, now I'm fixing some benchmark. Okay, I've kept 86% as the benchmark. Okay, if that predicting 86% or above 86%, you say that the prediction is passed. Otherwise, the prediction is failed. We check it how many are passed and how many are failed. So here The first four are all are below 86. Remaining all are above 86. So for 4 passed, 4 failed. 50% only, right? The accuracy of this model. 50
Vijay, can you scroll up to our example? Like, just a simple question I have. Just a top.
Mhm.
Yeah. So here, 25, 30, 27, 32, right? Increasing by a linear 5, increasing by 5 actually here. So can we train the model like increasing by 5 like this?
What increasing by 5?
Sales is increasing by 5, 9, 39, increasing 44. So if it next is, sales is 40, definitely it will be 45, right? So can we train the model like this actually?
Between temperature and sales.
Yeah, temperature and sales. If temperature is like 40, the sales will be 45. If temperature is 50, sales will be 55.
See
So it's
the same thing I provided to the model, right?
but here prediction is it's not
That's
coding.
27, 25 to 30. Same thing. See this 20, 27, 32, 29, 34, 31, 36, 33, 38. Now I've transformed that into label point and I've provided it. If you see same label point, you will get 30, 25, 32, 27. Yes, the same thing I applied the label point to this model to train. So it was that using that model only I was trying to predict with the features. Tomorrow temperature is so and so. What will be that? I've given the feature value. It was predicting that.
But the
So
prediction is like not accurate, right? Here.
it doesn't mean that all that will give accurate 100% accuracy. You cannot achieve there. Anything, right? 100% accuracy means if you keep on okay. 1 second. So once you try with re-execute with 1 lakh iterations, and you check the accuracy of all those things, you won't get the same values. You will get different values. Okay. Fine. So I'll forward you this once, check with these things, right? So linear regression with SGD. So one more example I'll show you. Some more examples I'll show you, right? And linear regression, logistic regression, the tomorrow session. Okay, fine. So here, linear regression with SGD, directly we have used the built-in functionality. But actually, if we go with mathematically, right, lot of steps required to perform it. Just we use that inbuilt functionality, we have imported it and we used it. Directly, linear regression with SGD, that built-in functionality. Okay,
Vijay, can you forward the notes, please?
I'll forward. Check it.